Welcome to 2026. In our first week, we learned that the ancient universe warmed up before it lit up. A rocket test proved bacteria can survive launch and re-entry, and new evidence for Mars's solid core was found. This is the wrap of the past 6 Talkin Science Daily Bites. Astronomers hunting for the evidence of the light from the first stars and galaxies have found that the universe was warm rather than cold before it lit up. The Curtin University-led team from the International Centre of Radio Astronomy Research was searching for the elusive epoch of reionization using the Murchison Wide Field Array Telescope, which is a period early in the universe's history that is predicted by theory but is yet to be detected using radio telescopes. It signifies the end of the cosmic dark ages, roughly a billion years after the Big Bang, when the gas between galaxies shifted from opaque to transparent, allowing light from the first stars and galaxies to travel throughout the universe. Dr. Nun Hockey explained that to study this early period of the universe, astronomers must isolate the faint signal from the epoch, identify and remove every other source of radio waves in the universe from their observations. The quality and quantity of this new data sets are what made this discovery possible, according to the team. A cold universe would have produced a signal that would have been visible due to the MWA's extensive capabilities. The lack of that signal rules out such a cold start to reionization and means that the universe must have been preheated before reionization happened. The initial paper, Limits on the 21 centimetre power spectrum from MWA observations, was published in the Astrophysical Journal on August 8th last year. A world-first study has proven microbes essential for human health can survive the extreme forces of space launch. Space agencies are planning to send crews to Mars and the Moon within decades, but sustaining life on the red planet and the lunar surface would be more difficult if important bacteria die during the flight. Now, an Australian-led study has found the spores of Bacillus subtilis, a bacterium essential for human health, can survive rapid acceleration, short duration microgravity, and rapid deceleration. Study co-author, Distinguished Professor Elena Ivanova from RMIT University, said the findings add to our overall understanding of how living organisms respond to the unique environment of space. Although humans have been living on board space stations for short stints since the 1970s, bacteria like B. subtilis are important to sustain healthy human life over decades, which will be needed for future lunar and Martian colonies. B. subtilis bacteria contribute towards supporting the immune system, gut health and blood circulation. Fluids may have flowed within the parent body of the near-Earth asteroid Ryugu more than 1 billion years after it formed, according to research published in Nature. The findings indicate that such bodies, known as carbonaceous asteroids, may have retained 2 to 3 times more water than previously thought. Understanding the history of fluids on carbonaceous asteroids is important as it can have implications for the origin of water on terrestrial planets. Carbonaceous asteroids, rich in carbon and water, are the most common objects in the outer regions of the asteroid belt of our solar system. They are thought to have formed from dust and ice in the outer solar system and may have delivered water and other substances to the terrestrial planets. Figuring out the aqueous activity in such asteroids can provide insights into their evolution, although some analyses of carbonaceous asteroids, including Ryugu, have identified fluid-rock interactions within a few million years after parent body formation. Longer-term aqueous histories have been poorly understood. Researchers from the University of Western Australia noted the International Centre for Radio Astronomy Research have uncovered an immense structure which spans an astonishing 185,000 light-years between galaxies NGC 4532 and DDO 137, located 53 million light-years from Earth. The study, published in the monthly notices of the Royal Astronomical Society, also revealed that a vast tail of gas accompanied the bridge, extending 1.6 million light years, making it the longest ever observed. The observations were part of the wide-field ASCAP L-band Legacy All-Sky Survey, which maps the sky and studies the distribution of hydrogen gas in galaxies using the ASCAP radio telescope. Co-founder and ICRA UWA astrophysicist Professor Kenji Becky said researchers discovered the colossal gas formations by using high-resolution observations of neutral hydrogen. Evidence for a solid inner core in Mars detected by NASA's InSight mission is presented in a study published in Nature. It furthers our understanding of the properties and evolution of both Mars and similar planetary bodies. Dae-Yuan Sun and colleagues used seismic data obtained from NASA's InSight mission to investigate the structure of the Martian inner core. The measurements suggest the presence of two seismic phases, PKKP, the deep core transiting phase, and PKIKP, a reflected seismic phase used to indicate the presence of a solid inner core, as previously demonstrated for the Earth and Moon. The seismic waves from the PKKP phase arrived at the seismometer on the InSight lander between 50 to 200 seconds earlier than would be expected if the core were purely liquid, suggesting that solid element to the core's structure. Further calculations based on these figures allowed the authors to constrain the radius of this inner core to about 600 kilometres. This finding provides direct evidence of a solid inner core on Mars and offers insights into the evolution of the red planet. Next year, humans are set to return to the Moon for the first time in 55 years with the Artemis 3 mission. Artemis 2 coming up in a couple of months apparently, where they're going to orbit the Moon. Looking forward to that. Now, while the astronauts may spend less than 10 days on the lunar surface in those future Artemis missions, scientists around the world are already preparing the next steps: how to live, grow food and thrive beyond Earth. A global consortium of more than 40 scientists from 11 countries and 7 space agencies has developed a new roadmap for the plant, science and technology breakthroughs needed to make long-term human life on the Moon and Mars possible. The authors introduce a new Bioregenerative Life Support System (BLSS) readiness level framework, extending NASA's crop evaluation scale to assess how effectively plants can recycle air, water and nutrients in space habitats to ensure they not only provide nutrition but also other critical life support functions to support sustainable human deep space exploration. The research builds on discussions from the International Space Life Sciences Working Group Plants for Space Exploration workshop, held during the European Low Gravity Research Association conference in Liverpool in 2024. Professor Matthew Gilliam, Director of the Arc Centre of Excellence in Plants for Space at the University of Adelaide and co-author of the study, is quoted by Scimex as saying, "This work shows how discoveries made for space can help us build a greener, more sustainable future on Earth." He goes on to say, "The innovations that will keep astronauts alive on the Moon, such as closed-loop farming, recycling and resource efficiency, are the same technologies that would transform how we grow food and medicines on demand anywhere on Earth, from inner cities to remote regions at any time of the year." More science and space news with an Aussie flair in 2026. Plus the occasional science fiction podcast. Like, follow and subscribe for more. Membership helps me do more. Get on board and help out for the cost of a cup of coffee a month. thetrek.zone/support.